Okay, we will not anymore answer 2.8 because it's proving. I leave that to you as an exercise. We go to other things here that we can answer directly in relation so far to the principles that we have discussed. Okay, the pyrolysis of ethane proceeds with an activation energy of about 300 kilojoule per mole. How much faster is the decomposition at 650 degrees than at 500 degrees? Okay, sige. So 2.9. The activation energy is already given. So we have the activation energy. Wait, class, huh? Oh. The activation energy is 300 kilojoule per mole. How much faster is the rate at 650K compared to rate at 500? Is that K or is that C? Let me check. Oh, 650 C and 500 degrees Celsius. So it should be changed. So this is Celsius. And this is Celsius also. So this is very easy, right? You're given already the activation energy. And by the way, this is also E. Some books will represent it as capital A. Some will represent it as E. So you need only the modified Arrhenius equation in which you're dealing with a pair of rates and a pair of temperature. So if you're going to write, or sige, I will not answer this. Maybe somebody would know how to answer this one. I am waiting for a volunteer. How would we answer this? Earl, let us hear your voice.
Hello, Miss.
Yes, Earl, can you dictate to me what should we do in this case? Yes.
Ang question ng Miss nga how much faster bala Miss do ka ratio bala Miss ang
It's a ratio.
first to ka mo.
So if it's a ratio, then can you tell me how do we come about finding that ratio? R at 500 degrees Celsius compared to R at 650 degrees Celsius. What do we know so far of this based on Arrhenius? This is E, right? E over R. What do we have then? 1 over T at 650 minus 1 over T at 500. Is this right?
Yes, Miss.
So you have activation energy is 300 kilojoule per mole. Since this is joule, what would be the R that you should use? What's the universal gas constant you will use?
8.314.
Okay, 8.314. This is, what's the set of units?
Kilojoules per mole, okay.
Is this not kilomole? Is this just per mole? So this should be, please check your units. So kilojoule per mole per Kelvin, that's it. this temperature here should be absolute. So it should be 650 plus 273. I don't have a calculator here. What's 650 plus 273?
923.15, Miss.
0.15, and we have 1 over, so this must be 773.15. And you get to cancel this one and this one, and this is actually 1 over k, so it gets to cancel with this. Okay? Your rate at 500 degrees C is equal to, what's your answer? 300 divided by 8.314 times 1 over 923.15 minus 1 over 773.15.
Negative 7.58 times 10 raised to negative 3, Miss.
Negative. Oh, it's negative because we don't have the negative sign here. Okay? So, what's the answer?
7.58 times 10 to the negative 3, Miss.
Negative 3. So, if the question is how much faster is 650 degrees Celsius rate compared to 500 degrees Celsius rate, then it could be rephrased in this manner. You can place this one in here and the 650 in here. So, your rate at 650 degrees C is what?
7.8 faster, Miss.
No, it should be reciprocal. Let me go back. You place it here, you place it there, so it would be how many times than that of at 500? Should be your 7 point, this should be transferred here. So 1 over 7.58 times 10 raised to negative 3 is
132, Miss.
132 times faster than the rate at 500 degrees Celsius. So look at it. Just the mere increase in temperature of 150 degrees Celsius, this is how much faster it is compared at 500 degrees Celsius. So that's your answer. The rate at 650 is 132 times faster than at 500. Okay, we move on. Now in 2.10, you're given a 110 Kelvin, at 110 Kelvin, normal nonane thermally cracks or breaks down into smaller molecules 20 times as rapidly as at 1000 Kelvin. So a change of, or a difference of 100 Kelvin. Find the activation energy for this decomposition. I think you know that, how to process that, so we move on that way. You won't have any, we will maximize the use of our time here. Kay sulit-sulit lang na siya, puro lang ni sila Arrhenius nga duwa. So we go to 2.11. In the mid-19th century, the entomologist Henry Fabre noted that French ants, garden variety, busily bustled about their business on hot days, but were rather sluggish on cool days. Checking his results with Oregon ants, so he compared this with the Oregon ants, he found that this is the running speed in meters per hour for the temperature recorded. What activation energy represents this change in bustliness? Okay, I give you a minute or so to read again the problem and understand what it's talking about and what it's asking from you. Okay. How do you understand this? Or how do you think should you be able to find the E, the activation energy for these ants? You're given the running speed in meters per hour against the temperature or on a particular temperature in a time of day. Anybody who has an idea? You're given speed. So actually, it doesn't talk about reaction rates, but it's comparable to, in principle, you can still apply the rates of reaction in here, or specifically the Arrhenius theory. So does anyone have any idea on how are we going to go about determining the solution to this? Okay, I will get the picture of the data so I can write it down in the... I will be waiting for those who would know how to find their way through the required information here. Okay, so we'll go to the whiteboard. Okay. This is your data. So I'll place here rate in terms of meters per hour. This is the running speed and this is temperature in degrees Celsius. 150 and 13, 160 and 16, 230 and 22, 295 and 24, and 370 and 28. Okay. That's the data that you can work on. You are asked for the E. How would you go about finding the E or the activation energy? Anyone?
Miss, nang ma-use ka sang Arrhenius equation.
Okay, so we'll use the Arrhenius equation. Of course, thank you. So you have K is equal to K sub O, E raised to negative E over RT. What do I do next, Iha?
ELN both sides.
Correct. So we get the ln of both sides, ln K sub O, and I will split ln of E raised to negative E over RT. ln of K, ln of K sub O, then this must be negative E
E
over RT.
over R.
Okay.
Tapos, okay.
Then,
Nang ang
you want to rewrite negative E over
E over
R
RT.
times 1 over T. So, para forthcoming na, obvious na kung ano ni siyang
Yes,
ginaubrata.
Miss.
ln A sub O. Then,
nang isolve lang, Miss, ang slope, which is ang negative E over R.
before you can do the
Ay.
slope, Iha, what do you do? Before you work on the slope, by the way, who am I talking to?
JB, Miss. Hava, Miss.
Okay. Javi,
Yes, Miss.
sige. Before you can even find the slope, Iha, what do you do? What would you do with the data?
I-plot, Miss.
I-plot ang data. Oh, wait. So, your Arrhenius, wait, your Arrhenius is giving you, I'll write the equation that you have dictated to me. So, this is the ln of K and you have negative E over R times 1 over T plus the ln of K sub O, right?
Yes, Miss.
Okay. Now, your data, I'll place it here, is rate against temperature, right?
Miss.
Then how would you treat this data? This is rate and this is temperature. What would you do?
Isundon siya gali Miss sa equation tanga na form na.
Like so we have this equation. So if this is your equation, by the way, why did we write it in this form? If you know, why are you writing in this form? What is this in the first place? What is this?
Linear equation, Miss.
Very good. It's a linear equation. You have a y. This is your m.
X can be a y-intercept.
And this is your y-intercept. Correct. Then, your data is rate and temperature. Will I be dealing, so my next question would be, you are correct when you are in this particular train of thought. I will use Arrhenius, I will convert it into the linear form of the equation. But the next question is, will you be dealing with the raw data that's provided by the problem? When I say raw data, as is, where is data?
Masunod ka na lang Miss sa gin-form tanga equation.
So how do I sunod, or how do we go about making, or shall I say, how do we go about applying the equation that we just linearized to our data?
Ang R Miss, di ba Miss, amo na siyang K Miss, ln Miss. Tapos ang T, 1 over T.
Okay. You are correct when you say that your R could just be replaced by the ln, because if you have the rate equation, and just for the reference of everybody, if you have the rate equation, your rate equation is directly proportional to K and C. So if there's an increase in K, the rate increases. If there's an increase in concentration, same thing with the rate, it increases. So that's correct when we speak that the rate here will be your K. That the rate in here should be the K that you have in this equation. So what do you do with the rate here is, so tell me, what do I do with the rate? I will What do I do
ln
with
siya Miss.
Okay, you get the raw data and perform ln to that. So you get the ln of R. What about the T?
1 over T Miss.
Okay, don't forget to convert it to absolute and get the inverse.
Okay,
It should be 1 over T and this should be in Kelvin. Okay, the one that is provided in the problem is in Celsius. So when we use Arrhenius, your temperature should be absolute temperature. So when you have that, you have this data. What do you do next? You
I-plot na siya Miss.
Okay, so you linearize. So if you have a plot, in our case, pila to kabilog aton data, you plot
5 Miss. Yes.
5. What do you do with this 5? When you plot, what do? You
Form a straight line.
you just get the best fit line. Not necessarily that you will pass through, right?
Yes, Miss.
And your calculators can do that for you. Okay?
Miss.
So the corresponding slope of this line, you equate to negative E over R, whatever is the slope of
Yes,
this
Miss.
line. With the appropriate R, you will be able to get the activation energy. Okay?
Yes, Miss.
Okay.
Miss.
Don't do average. Okay? My previous students would sometimes, some would sometimes suggest that we average. What do you mean by average, miss? Like they would deal with this set, get the E, deal with this set, get the E, you get what I mean? And then the E that is taken here is average.
Yes,
We
miss.
don't do that. When we get the best fit line, we draw the line that is appropriate for the set of data points that we have. Not that, okay, if you do it like this, it's just like, say for example, you have this dot. What you do is you like that, you get the E here, then you get the E here, then you get the E here, then you get the average. That's not the right thing to do. But rather, draw one best fit line that will represent your data points. So you don't get, you don't use the ratio formula and get the ease and then average, but rather you really need to plot. In your case, you don't need to plot because you have your calculators that can do that for you, right? You just use the application there in your calculators can do that. My students can do that also before. Okay? You just get the M. Any
Yes,
question?
miss.
Hello, miss.
Yes.
Mamangkot ko tani bala miss, in case bala miss nga if hindi siya miss straight line miss.
Hindi,
Ang
gina
na
siya mag-straight line. Marcel, hindi gina siya
kun
mag-straight
wala
line.
bala kun hindi siya bala miss, hindi ka makabutang do ka best fitting line bala miss ha. Kay medyo lagyo gid gapon ang data bala miss ha. Pag-plot
Oo.
mo.
Oo.
What will happen miss? Or same lang gapon gamiton mo lang siya gapon miss or kay since nga
Sa
hindi
miya,
man
base
straight.
miya, ready nga pointo muna. Ready iba, no?
Mm.
You still use the best fit line. You just use the
Okay.
best fit line. Get the slope of that best fit line that will point out to you the activation energy. Get the y-intercept that will give you the frequency factor, the K sub O. However,
Okay, miss.
then you see that value of R when you get the best fit line. The nearer the value of R to 1, the 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 more representative is your line equation for your set of points. Pero the more the R value deviates from 1.0, let's say for example, ang R mo sa imo best fit equation nga line is 0.7, meaning the equation of the line that you have is not really that accurate line that will best represent your set of data, meaning there must be some points that are really very far from the line that is represented by that equation. But the nearer to 1.0 is the R, then most of your points are right on the line or is very, excuse me, very near the line that you have drawn. Pero ang procedure, Marcel, is really like that. Whether you have a very crude equation of a line or a very accurate equation of the line with an R equal to 1.0, that's how you still determine the activation energy based on this procedure of linearization.
Okay, miss. Ano na last na lang gid miss? Gaulan ni kun wala ni miss ang given bala miss nga activation energy or wala gid activation energy, paano ta nakahambal din miss nga pwede ta magamit ang kinetics sa amo ni nga mga data? For example, gigaan ta running speed and temperature.
So, nano yaman koton? What will he ask if he does not give us the activation energy in the first place? Then the author of the problem must be making a problem erroneously. That is the case. So there's no point in doing what we're doing.
Okay, miss. Noted.
Okay. Sige, some more questions? Class, I will need to dismiss you by now because at 2 o'clock we will have an emergency meeting with the dean virtually. So I'm just online because they are in school and I'm here at home because I have a class with you. And the rest of the DCs doesn't have class. I'm the only one who has a class right now. So I will have to cut this short. We will have a meeting by 2. Anyway, I will share the recording of this to you. Some of you probably have seen on Canvas. I'll stop sharing. Some of you probably have already seen in Canvas the next problem set, which is a derivation of the formulas related to what we have discussed last Monday. Please work on